Great. Thank you guys for letting us know where you're from. We have a wide variety. I saw Maryland, I saw Florida, I saw all across the state of Ohio. Welcome to Soil Health webinar for today on February the 13th. I'm Gigi Neal. I will be your host for this morning, as well as Manbir Ricard and Asmita. Today with us, we have our speakers, Dr. Florence Sessoms and Dr. Brian Arnall. To give a little bit of background information for the two of them, Dr. Florence is an assistant professor of roots, rhizospheres, and resilience at The Ohio State University. Her current research is focused on plant interactions with soil microorganisms, maintenance of ecosystem services under reduced input management, and biological nitrification inhibition in turfgrass and other agricultural crops. Dr. Brian Arnall is a professor and precision nutrient management extension specialist at Oklahoma State University. Dr. Arnall's extension teaching and research efforts are focused on precision technologies and nutrient management in all of Oklahoma's cropping systems, with an emphasis on site-specific techniques. He works closely with extension educators and industry personnel to improve nutrient management practices that lead to increased profitability for producers. Welcome, Dr. Sessoms and Dr. Arnall. I will stop sharing so that you can share.
Good morning, everybody. Manbir, should I start? Is it up to me now?
Yes, we can see your screen.
All right, so thank you very much, Gigi, for the nice introduction. Hi, everybody. My name is Florence Sessoms, and I'm, I would say, 2 years new now to Ohio State. Before I was in Minnesota. And prior to that, I did a postdoc in upstate New York at Cornell, and did all my education in France and Switzerland. Actually, I did my PhD in Switzerland. So first of all, thank you for being here so early. I mean, today I'm going to talk on the basics of biologicals, but mostly I'm going to really dwell into arbuscular mycorrhizal symbiosis, because this is what I did my PhD on. So, you know, oops, sorry, how do I click for? All right, so when we think about biological products, what are they? You know, they have many different names. They are called biostimulants. They're also called biofertilizer. And so what are those? In fact, they used to be microorganisms that were naturally occurred in the soil. And they have been collected, extracted, grown artificially for mass production. And so what do you do with them? So the idea is, like, when you apply to plant or in the rhizosphere in a soil, they will stimulate like processes that are benefit for nutrient uptake, nutrient use efficiency, and improve the plant tolerance toward different stresses. So what are those microorganisms? They can be either beneficial bacteria or fungi. And today, to understand of how to choose the appropriate, like, I would say, biostimulant or biofertilizer, I think you need to have a better understanding of, like, the product, of its biology, but also how it can interact with the plant. So for that, I'm going to give you the example of, like, arbuscular mycorrhiza fungi that are used generally as biofertilizer and sold as inoculum. So, you know, if you currently, if you go on Google and you do a Google search, and you go on Google Shopping, and this is really an image that I've snapshot from yesterday. This is everything that you will get. And you can see that there is many different products that are currently available for the general public. The idea is, like, how do I choose the best product, or how do I understand which product would work best for the type of, like, plant growing that I'm going to do. So first, you need to understand how this interaction works. So how do they establish? So in the root. So this is a symbiosis. You have spores that are generally sold. So when you buy an inoculum, you generally buy a mixture of different spore propagule. The spore is going to germinate and be germinate. and go in the direction of the plant. Grow in the direction of the plant. And why? This is because the plant is going to recruit the fungi through the production of compound. And then in exchange, the fungi is going also to secrete all the compounds that are going to prepare the plant for its arrival. So there is really an initial exchange between the fungus and between the plant to prepare for the symbiosis establishment. When the fungi, the mycelium of the fungi, reach the plant, it would form an hypopodium and then penetrate inside the roots, where it's going to form this arbuscule structure. So why are the arbuscule very important for this association? This is because this is the site of nutrients exchange between the plant and the fungus. So in the arbuscule structure that are going to be inside the cell, nutrients such as phosphate, nitrogen, and water are going to be transported to the plant. How this is, the fungus is going to grow, also develop a large mycelium all around the root system and forage for this nitrogen, for the phosphate, and so for water, and going to bring it and transport it and give it to the plant. But nothing is free in this world, so there is an exchange. And in exchange, the plant is going to give carbon and lipid to the fungi. And it's very important to understand that, because we call arbuscular mycorrhizal fungi obligate biotroph, meaning they cannot survive without the presence of a host. Without this carbon, without this lipid, they will not develop. And if they don't develop, they cannot forage for the nutrient, for the water that they're going to deliver to the plant. And hence, the benefit of the symbiosis will be lost. All right. So at the difference of a pathogen interaction, you don't see really disease, a discoloration of the roots, when you have a mycorrhizal association. So in fact, to be able to visual the structure, the fungal structure, us researcher, what we have to do is discolor the root, clear the root, and then we have to stain. And I wanted to show you how they look like inside the plant. So here, this is a stem structure of a Napressoria or cods, the little arbuscule that are little tree-like structure inside the cell. What we call on the left side infection unit. Sometimes you have vesicle inside the roots, and here this is external mycelium with with spore being produced. Okay, so there is various benefits that in the literature that have shown to be provided by the arbuscular mycorrhizal symbiosis. And they are, as I said previously, they can increase mineral nutrition, such as nitrogen, phosphate, and other macro and micronutrients. As a result, it will lead to increased biomass accumulation. But there is other benefits, such as resistance to drought, resistance to stall stresses, a better tolerance to cold and heat stresses. And more recently, we are really observing this plant priming effect by the mycorrhiza induced resistance. So basically, mycorrhizal associated plant will be better resistant toward certain pathogen. All right. So, the benefit, they have been observed in with plants that were colonized with arbuscular mycorrhizal. But, in fact, these observed benefits are highly variable. You don't see them all the time. And this is because even if we think that arbuscular mycorrhizal symbiosis is not host specific, meaning that any arbuscular mycorrhizal fungi could, in theory, infect and colonize any plant, there is a certain host speciation. And this is a very nice paper that really shows the host speciation of plant and mycorrhizal fungi. So here, this is a graph of 64 species that were colonized by only one mycorrhizal fungi. And you can see on the left, this is a plant that showed an increase in plant biomass, whereas on the right, this is all the species that showed a decrease in plant biomass. In this paper, they also looked at different plant species colonized by 10 different mycorrhizal species. And you can see that the response of the plant for each mycorrhizal species was highly variable too. So clearly, as a summary of that, the arbuscular mycorrhizal, arbuscular mycorrhizal benefit, or here this is increase in plant biomass, or can vary really in function of the host and the IMF genetic background. Right. But there is other factor that can have a huge influence on the outcome of the interaction. And it can be, for example, the initial soil microbiome. So, for example, when you plant a plant into a soil and you add like an inoculum of mycorrhizal fungi, it will have already to compete with like the presence of a very functional and established like micro population. All right. But also the environment factor. So what can work in a sandy soil may not work on a clay soil, because like soil are highly variable between the different area. pH could be a huge also factor that can influence the interaction. So like in addition to that, in addition to the environment, the soil, characteristic or the host and genetic background, for arbuscular mycorrhiza symbiosis, certain nutrient availability already present in the soil can have a huge influence of the fungal establishment. So this is a case of phosphate. Phosphate is a major regulator of like arbuscular mycorrhiza symbiosis. So here, this is a graph that of like my PhD, where we can see that the colonization decreased with higher concentration of phosphate. And why it's important? This is since it's an obligate biotroph. Well, you can imagine that with like higher phosphate concentration, where you have below 10% of colonization, it means you have also a very, very narrow mycelium around the root system. So the benefit of the interaction will be extremely low in that case. All right. So in summary, really, of like these what I just said, they have shown to provide many benefits, but the outcome of the interaction are variable due to the factor of like the genetic background, the soil type, the native population, and the fertilizer management practice. So what I want to say really about that, this is that when you take, I think, when you take an inoculum, you have to be careful really of like what type of species you are going to use. And also, so I will encourage you to go, for example, on the website of the provider and see what type of experiment and which type of plant they have done their experiment. I would also encourage you to, when you inoculate them, to inoculate them as close as possible of the root system, because there is this interaction between the spore and the roots, and they need to be in the vicinity of each other for great establishment. And also I would be careful of like the management, the nutrient management you are using in your you are using, and especially be careful of the amount of phosphate you are applying. Sorry. Yeah, sorry. No, okay. So I would say the same observation for any rhizobium also inoculant. So rhizobia are bacteria that are able to fix nitrogen, and they also form like an association with legumes, and that can be observed by the production of little nodules in the root systems. Basically, they are thought to increase the fertility in agrosystem, increase the resistance to biotic and abiotic stress, and be more a sustainable practice. The main issue with rhizobium, there is here really much more like a higher host specificity than mycorrhizal fungi, meaning that you cannot use any rhizobium species on any legume plant that you have. For example, Bradyrhizobium japonicum would only work with soybean. And if you were like growing a common bean, you will have to make sure that your inoculum possess, for example, the correct species of rhizobium, such as Rhizobium phaseoli. So this is again very important that when in function of the plant you are growing, and if you want to use like a rhizobium inoculum, you make sure that the species that you are always using will actually work with your plant, your host plant. Now I'm going to finish this talk, this small talk, by like other type of like bacterial inoculant. There is a plant growth promoting rhizobacteria that are known for their phytohormone production, and there is many species that are like categorized as PGPR. There is also the free living nitrogen fixator that are like bacteria present in the soil that can fix nitrogen. But this is the same context for like bradyrhizobium, like the nodule symbiosis, or even the arbuscular mycorrhizal symbiosis. They still need to be recruited by the plants through the production of their root exudate, and they will have to compete with the initial like soil microbiome that's present in the soil. Finally, a type of like biological that I've not mentioned too is humic acid. These humic acids that are generally degraded organic matter that are thought to improve soil parameter and improve plant nutrition. And humic acid is also have been shown really to increase like plant nutrition or like water holding capacity. But humic acid is like a very large term, and there is different type of humic acid with different compound that have like different actions. And again, in the literature review, sometimes adding humic acid will improve your plant biomass, and sometimes they will not. So as a conclusion, I would say that I will not hesitate to do some research on the provider website. And for example, I worked with like a component from FMC Corporation, and I did a search and I found the patent of like the bacteria that I was working with. And on the patent, you have a lot of information of all the tests that were done by the company. So I would encourage you to go and read through the patent and see what the bacteria is able to do and not able to do, and then you can use it more efficiently for the type of like plant that you want to use it for. So thank you for your attention. Sorry, that's like, and if you have any question after, I would be happy to talk about it, to answer your question. And otherwise, here is my email address. It is sessoms.5@osu.edu.
And next up, we have Dr. Arnall from Oklahoma. Oh, Ron Snyder has raised his hand. Ron, do you have a question?
Oh, should I answer the question? Sorry, I'm not familiar. Okay, so one of the question of Eddie Wester's website for us to do the research, please. So this is what I do when, for example, I was looking at mycorrhiza or sustain mycorrhiza product, mycorrhiza Harrell or sustain sorry okay, sorry, and other websites. So I directly go on their website and look at their product and see like the claim that have been made on the product. I also look, if there is a patent, I also look for the patent associated with the strain for the bacteria, especially with the strain that is like described on the packaging. For the mycorrhizal fungi, I try to look at the packaging of the mycorrhizal fungi, and I look at what species they are using, but also what the amount of propagule they are using, for example, the amount of spore propagule per milliliter or per gram of soil. And I will encourage you to take like an inoculum that have more than one mycorrhizal fungi and with the highest amount of propagule in per gram. Why? This is because if you have more like mycorrhizal fungi, more species and more like number, the probability that it's actually going to infect and make like a dense colonization is higher.
And we do have one more question, and then after this one, we will go to Dr. Arnall and We will have more time at the end for more questions, Q&A.
Okay.
What
So what
type
type?
of humic acid is better?
So I'm so sorry, I really not can answer this question. I'm not familiar with humic acid. I will say, like really, they have like different different humic acid can really have different result. I had, let me see if I can find it. So basically, there is different like group that are associated with humic acid: carboxylic group, phenolic group, aromatic group, and aliphatic group. And some carboxylic group and phenolic group are like more like geared toward like an improvement in the soil physical properties, whereas the aromatic group and aliphatic group are more like associated with like a stimulation of root growth, nitrogen uptake, and sugar production. But the issue is when you go at packaging, you know, like for example, if I go back to like the packaging from like, for example, Sustain, it's like it's just written humic acid. So that's where I will actually like call the company or look on their website if they can give a little bit more information in the type of humic acid that they have and to make a better decision.
Okay,
We good to
Dr.
go?
Arnall, would you like
All
to
right. Fantastic.
share your screen?
Yep. Well, happy to be here. I appreciate following Dr. Sessoms. She gave some great background. I'm more agronomic in what I want to speak on, and I want to say that this is a really big highlight of a large slide deck that I use that usually goes 45 minutes to an hour because I've accumulated data from multiple states. I also say I've been testing biologicals and agronomic systems since about 2009, and I've had a whole variety of outcomes. And so some of the thoughts that I share is an accumulation over time, not necessarily just the data that I'm going to share from a multi-state project, which is just going to be a little bit. One thing I really talk about though, and probably where I'll spend most of my time, is that there's an issue with the biological product community right now in that we're not providing a lot of information. There's no regulation, there's no quality assurance, no QC, QA, and it's not likely to come soon because, you know, there's a discussion, is this EPA, is this state, is it USDA, who should be in control of it? And then if there is somebody who's going to regulate, who's going to do the testing, who's going to do the assurance of it? Is it the state level like we do fertilizers? Is there going to be overarching labs? How do we test and do that? And so while we don't have regulations on QA, QC, which will come up later, one thing that I would really, and I'm really pushing companies are, is that we've got to look at these products more as a function or a mode of action, because everything that you have has a mode of action or a function or a mechanism that it's trying to influence into the system. Dr. Sessoms did a really great job on identifying a few of these, and this is kind of how I break out mine when I'm trying to introduce this. And think of it this way: think of it as a herbicide. You're not going to go out with a mode of action that has no relevance for the weeds you're going to control. You should be looking for a function that you want to do in your system, and then finding a product that has a mode of action that fits the function and has application for your system. I'm going to break down what I mean. One, these are my groups. So the N2 fixers, you know, the rhizobia, those things that are bringing in atmospheric nitrogen and making it plant available. Very easy to describe what that mechanism is. The function of it, though, would have to be that you're only going to get a value from a nitrogen fixer if you under-fertilize. You're not going, by adding more nitrogen to the system, if you're already over-fertilizing, you have no value. So if you want to use a nitrogen-fixing bacteria, it's either as a safety net that you're hoping that if you do under-fertilize that it can compensate, or you go in mechanistically and say, you know what, I'm going to under-fertilize so this biome is creating nitrogen for me from the atmosphere that I can take advantage of. The other group that I play in is the symbiotics and symbiotes. A lot of those would, they can play into the N2 fixtures if we talk about rhizobia, but I'm thinking more the AM scenario. And these are a really fascinating group. Dr. Sessoms, I don't want to go into much because she's talking about, you're increasing the root mass. You're doing a lot of things, and there's also a lot of back and forth of, is it first or secondary? By getting AM, by getting that fungal mass, the fungal mass itself can improve the water retention of the soil, and you're also maybe delivering more plants. So there's some back and forth of the benefits. I want to highlight, and I want to star, and I want to do everything that she said, is that in almost all research that I've come across as a soil scientist, you have the symbiotic relationship is one that the plant and the AM is talking to each other. The plant is saying, I need a relationship with you. I want a relationship with you. There's a reason for us to be together. It's not just there's a fungi in there and it just says, I am making a relationship with you and you're going to benefit from me. This is where some of the challenges and implementation of this comes in, I do believe, is that we've got to have that plant also saying, I need a relationship with you. Work in Oklahoma on looking at AM fungi and sorghum is that we had great relationships with the two if the sorghum was stressed, specifically phosphorus or nitrogen stress. If there was no plant stress, then there was no relationship or extremely limited relationships between the two. Organic matter decomposers. Now, this is the one I think if you just do a Google search on what products are available, this is going to be the bigger hitter. This is going to be everything that says releases nutrients, right? And so there's a lot of things that we can place into our soils biologically that can help decompose organic matter or increase mineralization of organic matter. In that, we're talking about any product that says we increase nutrient availability probably is an organic matter decomposer. In my condition, I'm looking at fields that may have 1 or 2% organic matter. I don't want more organic matter decomposition. My decomposition is at a rate that's probably faster than I actually want anyways. So I got to be cautious about, do I actually want to add a biome, add something to the biome that's going to increase organic matter decomposition, which I'm going to drop down here, which would be like a biological stimulant, like a glucose sucrose, that if I add a glucose or sucrose, I'm going to boost that microbial activity of the current biome. I'm going to spike it up for a day or two. It's really going to consume, it's really going to release. Then I typically see a crash after I add a glucose or sucrose, or even the humic acids and fulvic acids. That's what we're doing. We're feeding, we're really boosting that biome with the biological stimulants. The mineralizers and solubilizers, these are kind of grouped together for me, is that you're either breaking chemical bonds or trying to get into mineral bonds and release. There's some new phosphorus products, or it's not new. There's products out there that, to me, in my head, make sense chemically, is looking at phosphatase and things that can get in there and break weakly bound aluminum phosphates, calcium phosphates, those phosphates that may not be plant available, make them a little bit more plant available. Now, there's got to be some right scenarios for this, right? It's like, okay, so maybe I've historically applied manures or over applied phosphorus and I want to completely get away from that fertilizer. I'm going to go to that bank on those weakly and a little bit more strongly bound phosphates by breaking them up and making them plant available. Although I've talked to producers in the Pacific Northwest that are using these that kind of scare me because they're excited about using them on soils that have a soil test value of 1 and 2 by releasing more. And at that point, do you really want to push your system to release more phosphorus in a system that's probably already mineralized all the phosphorus it wants to, and you're forcing it to go into more mineralization? I think there's got to be a fit for that. And then the one that I honestly think we're probably going to hold more long-term value in are the hormones and enzymes. And I'm going to say why, and I'm going to kind of give my answer, my conclusion in the beginning in this, is that we have been working with plant hormones and enzymes in plant production, crop production for a long time. We've been using PGRs in cotton production for decades. I understand how to use a plant hormone to change a plant and to facilitate crop production. We understand that. when I look at the functions here and the functions that we have to look at this realm, I have more belief after working these things for since 2009 that I can manage a plant by hitting it with hormones or enzymes probably more effectively than I can change the biome of the soil by adding a new organism to it. In all the years, I think I'm going to give you my conclusion before I show you my data. But my conclusion is that currently, with what we have on the marketplace, I am more confident in my agronomic management strategies and having a greater influence on microbiome of my soil than adding a product in or adding a new biology. The more and more I talk with microbiologists and folks like Dr. Sessoms, is I have a more strong belief that our native biome is native and there for a reason. They're extremely competitive, and we can change it through agronomic practices of no-till, of crop rotation, of cover crops, of mixing things. And that if we introduce a foreign body, that foreign body has to be really, really tough to outcompete the natives. And if it does, I want to get to this later, if it does outcompete, that may not be the best thing we want. Getting into data real quick, and I know I only have a few minutes, so I apologize. One of the things that we've done 2 years, and I know this is cotton, but I want to just tell the approach to this work and show how, and we're going further. 2 years multi-state across the entire cotton belt, and we looked at 8 national level products just to get a better idea of thinking, you know what, I don't expect something to work across the entire cotton belt, but maybe we can find that regions of it, because of soil type, because of weather, because of pH, because of cropping system management, maybe this one product type will work better in the southeast cotton belt or the western cotton belt. So a lot of states, a ton of data, and just showing you some of the data we've had and how we approach this, that we created a nitrogen response curve, because all these products said to improve nitrogen uptake, nitrogen management, increase nitrogen. So nitrogen response curve, so we know where we're at. All the products were applied at a base rate of 45 kilos. That's 45 pounds of N per acre, or 40 pounds of N per acre. And so the Brantha, Sato, Valent, all of them got 40 pounds. And that way we can look back and say, okay, where on this response curve was this product? Did we get 10 pounds, 5 pounds, 50 pounds, 100 pounds by adding this product? We did some analysis later I'll talk about, but going through the lint yields, this is year 1. Everything, these products are here, stated back to right here. We had no response across all sites. There was not a single site that had a significant treatment response to the biologicals in 2023. And so they were grouped together. We got a nice little nitrogen response curve. Here's our products we tested against the nitrogen check at 45 kilos per hectare or 40 pounds of N. Our 2024, same thing. We have a nice little response curve, not a great response, but we see this often in nitrogen studies. And this is across, this is 8 reported at the time, but we've got all 16 in. It really didn't change this curve whatsoever. It's bumped up the 120 pound rate. But we see also that we had really no response versus a 45 with the products. We go in by site year and actually look at the statistical analysis, and the only one where the micronutrients as an ANOVA, and I didn't like this analysis, and I'll get to it in a second, where the ANOVA showed a treatment impact by biologicals was one location in Texas, and in that location the product was less. So I think this is a mismanagement. I would not put that on the product. So the one time we had a significance, it wasn't in the positive level. I'm not going to go over the tissue results, but I want to go over, I did all the tissue results in Stillwater. I want to go over how I look at this statistically for the group, just briefly. Most people are using a ANOVA test where they're testing all the treatments together. What I'm trying to force my colleagues or get my colleagues to do, and we're doing more of it, is a test called a Dunnitz, or we're really looking at one versus the other. And so if I go back to this treatment structure, I only want to care what this Brant does versus the 40. I only want to care what Corteva does to the 40. I don't care about Brant versus Corteva. I don't care about it versus the others. And so it's basically a pairwise test where I'm only looking at every treatment back to this number 2 to see if there's a difference. And then briefly, I want to show you that we only had 3 or 4 instances where any of the additives increased one of our nutrients of all the mineral digestions. We had 2 that did nitrogen, and we had 2 that did zinc, and there's one other one floating over here. I can't remember one. One that did sulfur. That was in the first year, and so far in the 2024 data, we're seeing very similar, very little benefits. In my last 2 minutes, this is where I think the problem goes back to where we need to have regulation, and why regulations is going to be so hard is that the second these jugs were open, Dr. Tom Ducey with ARS out of Florence, South Carolina, took these samples and basically wanted to know what was in them. And so, doing things that Dr. Sessoms can explain much better than I can as a soil scientist, he did DNA extractions and did taxa identification. What's in them? And he did it for both years and looked at them and basically did it's there, I'm not sure, and no way that it's what they say it is. And in short, this is what he came up with over 2 years. And this is fresh right out of the jug. So the Brant was there. The Utricia was there. These 2 products weren't there. There's more slides to explain why that I can't show. He didn't have an Navita or the Contendrum, but these are kind of there, but it's like the species are there, but is it actually the functionality that they say that the function is that they're supposed to get on the label? And this is more of percentage than this one. So this goes back to the QA/QC. Are you getting what you think you're getting, right? This product right here claimed to have 800 species of biomes, the nematodes, protista, yeast, and so he couldn't test for all those. But looking at just the fungi and the bacteria, he was only able to find 40 genera. He also found in another product that wasn't in here, another product that was only supposed to have two species in it, had a whole host of other things, which Dr. Ducey come from the background of virologist. I'm getting over a flu. Human virology, duh. And he's finding in a lot of these jugs things that are not supposed to be in there. There's things showing up, showing that maybe the QA/QC in manufacturing isn't what it is, because there's things in there that aren't supposed to be there. Are they supposed to be there? Are they okay to be there? And he has concerns about immunocompromised individuals being around some of these products that don't have good QA/QC, because if it's in the bat and somebody sneezes on it, what does that mean about downstream? He's greatly concerned about this. And really thinks that QA/QC in the manufacturing really needs to be up leveled and upscaled, or more hazards should be potentially put on some of these jugs to know that, there could be things in there that can cross over and cause problems. Batch to batch consistency, he is seeing this problems. How are companies monitoring this? Are all microbes viable? He only did DNA, not living portion. And finally, in my last, I went over, and I apologize. The last thing that we get back to a little bit, Dr. Sessoms, can they colonize? Can they compete with native? In his concern, if they compete with native, are they kicking out a native species that has a function elsewhere? That's it. Just because they compete does not mean they might not outcompete an important species or important something that's in that biome that has a function elsewhere. What's going on in that biome as a whole when you introduce something? And he brought it up, and I've had others bring it up, is that I'm going to ask you this: what makes a good weed? I want all the farmers, what makes a good weed? It's something that is aggressive, reproduces rapidly, and grows rapidly. We're dealing with 3 weed species that were brought into the U.S. for soil and soil stabilization: Multiflora rose, kudzu, and Cerisa lespedeza. All these were brought in because they grew fast, they were able to stabilize the soil, and now they're invasive species. I had a biologist ask me when I first started working with this 10 years ago, are you soil scientists putting the next kudzu below ground? And I couldn't answer that question. And that's always resided with me as one of these things. I'm still testing this. I'm still putting them below ground. But she has always had that in the application of my mind. Application rates were one of his concerns. looking for positive field results. We did not test after we put it in the soil because we did not have the money. That goes to no whole other level to see, did it actually increase in the soil, and was it in the soil after application? I think this was his impacts on human health, impacts on soil health and function. Moving through here. Again, I've got, what I have done is I have collected every person. In fact, I'm going to ask Dr. Sessoms for her slide deck when this is over. Every time I visit with folks, every time I've talked to a new scientist, I request their slides and their data. So I've got stuff from the Pacific Northwest. I've got all the stuff from the Corn Belt, that Northeast corn output. I'm really just collecting data so that I myself can look at it and consume it over a broad scale of geographic environments, cropping systems, and soil types.
Thank you to both of you. Do we have any questions? Feel free to put them in the Q&A chat or the Q&A section.
We have a question here, Gigi. Says, what soil tests are recommended to help farmers determine the need for biologicals? Specifically, are the tests such as the PLFA useful?
For the test, I will look at organic matter and phosphate availability, especially I think for like at least if you were, for example, using mycorrhizal fungi. Why? This is because at the phosphate availability result that you will get will allow you to determine if like the use of your mycorrhizal inoculant is going to work or not. You know, for the PLFA, well, the problem is the PLFA, I think it's great, you know, just to see if you see change, you know, for example, in change in over time. And I don't know how if, in my opinion, I don't know if like just one like is like good enough. What you want to see, this is how like your PLFA is changing over time just to see if there is a benefit or not of your inoculant.
When with Dr. Ducey and other microbiologists, very similar answers to Dr. Sessoms is that test is a benchmark of how you're impacting your system. More importantly, make sure your pH, phosphorus, and all those things are good. That in all the work Dr. Ducey's done trying to improve biome, he's gone to places that should have zero biome, and he's excited about bringing biome in and creating it. But the native background biome was already there, even in places that it shouldn't be there. Is that the biome was identical to native range 6 miles away on what should be sterile soil. It just needed to be cultivated with organic matter, crop production, proper pH, organic matter. pH, I think Dr. Seth's right. pH and organic matter and phosphorus are huge.
Thank you. Good questions. We have another question. Do you have an enzyme or hormone test that supports your theory?
Which theory, Hetty?
All right. So that's like my, you know, like my input. I will just promote management practice. So that are beneficial for mycorrhizal establishment. You know, if you have like already perennial cropping system, there is a certain chance that you already have a native population. So of course you can apply your arbuscular mycorrhizal fungi. In my opinion, every time I have tried to apply mycorrhizal fungi, and I'm not working on a specialty crop, I worked with turf. So I've applied like a inoculum on many different turf field, and I never see a beneficial response from it. So in my opinion, based on like what I've seen, is like better to promote what you already have with management practice that are beneficial for the long-term establishment and the presence of your mycorrhizal fungi that are already here, you know. And it would be like reducing your phosphate inputs, planting species that are known to make mycorrhizal that are to promote like mycorrhizal symbiosis. And yeah, but especially, I would say, managing your phosphate level.
So Hetty did comment too that she's looking for the one that says hormone or enzyme are more influential.
So great question, and I'm glad you said theory because right now it is theory. This is more of me saying after 15 to 18 years of testing enzymes, hormones, and soil applied biome that I theorize that the greater impact is that I've not found one of those beyond PGRs, which is a hormone. So that would be the one. The PGRs, I can influence my crop structure with PGRs. I'm not finding one that is effectively changing my agronomic production system in a positive way. I'm just saying that in my background, that I have more hope going forward for those that are influencing the plant processes more so than the soil biome. And I could even say that I could see if we can get something that could stimulate the plant to signal for the soil biome to change. That has some potential. I'm not saying it's happening, but in theory, there's some stuff that could do that.
David says, great information, thank you, and wants to know, is there an effective way to apply AMF to an already established perennial specialty crop?
I'm so sorry. So I wanted to come back on what Brian had said a little bit there about like how to stimulate already, what you have already in the soil. So another project that I'm doing is how to, for example, stabilize nitrogen content in the soil is to inhibit nitrification. So the nitrification is a process that will transform ammonium into nitrate, and nitrate can be lost either by leaching or through denitrification process and as a gaseous form. So the type of research that I'm doing, and it's already been done since 20 years, is to promote species that are going to secrete root exudate that are going to inhibit the nitrification. So this is a way, basically, that is organic and very efficient because it's localized. You don't apply any chemical. You just let the plant do its job, and basically you can stabilize nitrogen in your soil. That could be like, for example, a way of conserving nitrogen. Again, for the mycorrhizal fungi, I will encourage you to adapt your management practice to promote the type of like the native population that is already present in the soil by I would say either like adding like organic matter or even making sure that you reduce like the phosphate fertilizer application.
That's a great question. It's beyond me. Maybe Florence has a better answer, but just listening to Tom, a lot of what he was talking about is during the process of manufacturing, clean out between runs, a lot of making sure that the human contact is food grade systems where everything had to be absolutely contained and contaminant free, mask, respirators, all these things. Again, as a soil scientist, I don't want to speak. I'm just trying to relate what Tom was sharing as I've done about 6 talks with Tom now.
And so the question was, what monitoring parameters should we put in place for contaminants that occur during biofertilizer preparation? Other questions? I think we have time for a few more.
I have a question. This is Jim Ippolito, and this is a question about how complex what both of you are studying or have talked about this morning. And the question is, how do we tease out the interactions between all these variables to provide farmers the best information so they can make an informed purchasing decision?
Just my two, all these are going to be exceptionally site specific in my opinion. So we've got pH by OM, and it's even across field. There's going to be, if it works, it will not probably work field wide. It's going to be location if you have a change in anything. And so this goes back to a lot of on-farm testing and doing it well, replicated strips. All these things can be done as replicated strips. We have yield monitors. We have different things we can do. So test. Do multiple strips, not just one half the field, the other half the field. And man, if it works for you, rock and roll. I'm just saying I've not found one in my environment that I am consistent with. And my last thing, Jim, as a state soil scientist and extension specialist, my problem is if I can find something that I know will work 33% of the time and I can identify that 33% that will work in, I will recommend it to the 33%. I need something though that's consistent in the wins and failures. A lot of this stuff, when I find a win, it's not consistent. And when I find failures, it's not consistent. A lot of this stuff is consistently inconsistent. So until I can identify environments that I can tell my producers this is where it goes or this where it isn't, I can't justify making recommendations. It's just a lot of these have done something, but I can't repeat it, or I can't justify why it did the one time out of 5 that it did.
And what do you think, Florence?
All right. Thank you very much. Okay. So I don't know. I think it's a complex answer, and I totally agree with what Brian said. I would say, like, for example, developing products that are more like site specific. I think, I don't know, maybe there is a market for that. Basically saying, hey, we have like all these lists of products, but there will be A, B, C rated in function of the type of soil you have. It worked great with clay soil. It worked great with sandy soil. It worked very good in loam soil. So also trying to use like more native species for the type of soil. For example, I have a project right now with the Ohio Soybean Council. We are trying to evaluate how the presence of like native arbuscular mycorrhizal fungi can positively affect the incidence of soybean cyst nematode. So basically after your recommendation would be like, here, this type of mycorrhizal fungi that is native to Ohio soil seems to do better, So that could be also a way of like dealing with things. I would say, for the farmer and for the company, a little bit more honesty. We don't have regulation really. So it's a free for all. Everybody can like sell and say anything because we don't have strong regulation. So I would like to see more honesty from like the company that are actually promoting this product. I think there is like an honesty not only in the type of product, but also like a little bit more like a clear guidance on management practice. I will say, for example, for some of the like the PGPR, I think they might work, but they might work in a very short amount of time. So it means that you need to reapply every 2 weeks or every 3 weeks like this. So yes, there is sometimes is a little boost, but it doesn't last because the bacteria cannot compete with the soil microbiome. So basically it's just like it's being like washed away. So you need to reapply these. So at the end, what I'd like to say also this is a cost for the farmer. The benefits are so numerous in terms of like better yield, better increase, better plant resistance. So it's always great to add them. And it generally, and maybe I'm wrong, but it doesn't seem to negatively impact the plant. I will say it will not kill your plant. A mycorrhiza will not kill your plant. But that's true that in some cases, you can see a decrease in plant biomass that could actually affect your yield. So it's a loss in economy. So I think my answer was very complex, but because also it's a very complex question. And I don't know, I think we need also maybe at the end, a better regulation to help the farmer to make like better choice too.
I'll say, Jim, I got a buddy who has been working for 6 years on his own product, his own tea, but it's for him and his fields. And he's found out that it doesn't work across his river. Like he's got some fields across the river, and that change in soil type doesn't work. And he's wanted to get it to me, but he also, from what he's found out, he's got basically 8 hours from tank to soil to get his product applied before it starts losing viability in the weather conditions. And so he's only done it for his own. I mean, he's a consultant. He's running like 6,000 acres. And so it works, but only on his 6,000 he's tested across, it only works on about 3,000. And so he's not looking to commercialize it. It's just, he's just doing it on his own, but he's found out that it can't go much broader. It's all within a single county.
Hey, Ron, I saw you had your hand raised earlier, so I gave you permission to speak.
Can you hear me now?
Yeah, there you are. Welcome back to Soil Health, Ron.
Okay, thank you. I'm going to assume you didn't hear any of it, but I agree with the presenters today. I'm looking at this from a producer standpoint. I've done biologicals for 5 years. I cannot get a yield increase. The only thing that I can see is disease suppression, and I'm using testing to prove that. And my theory, and I'm going to state that it is a theory, the best way that we can change the microbiome in the soil is to plant a diverse cover crop mix with the wide range of microbiome being added to the soil. If it is going to live in your soil, great. And your soil needs it, great. If it's not going to live in your soil doesn't need it. That's how I'm starting to look at this. And yeah, that's I'm going to do with it. I'm doing metagenomic testing. That's where I can find it out. And your weed comment early on, yes, water hemp added 95 species to my soil microbiome. I got a feeling that is why it's growing so well. Thank you.
Are there any other questions? Thank you, Ron. Ron was one of our panelists on the last session in January.
There is one remaining question, Gigi. I don't know if we want to maybe with time have that, answered in a different method, or we can ask it now.
Hayden, I don't have Johnson Sioux yet. Doing corn project with Kansas, and we're going to have that across. I do know several producers. I'm not aware of the KNF IMO.
If you have not already completed this CCA credits and scanned the QR code that is here, you can also log into the system and put your information in. Please make sure that you do this before you leave today. And also go to certifiedcropadvisor.org, continuing-education/missing-CEUs to see if you are missing any credits. We do have a couple other programs coming up on March 20th. What do soil tests tell us? And on April 10th, soil health in the urban sphere. We have a Conservation, Tillage, and Technology Conference on May 11th through 12th in Ada, Ohio. And also, if you're not familiar with our eFields reports or would like to have information about our eField, you can find that information here by scanning the QR code or going to go.osu.edu/eFields. And I will go back to the QR code so that anyone else who is needing to get the CEU credit for CCA, please make sure that you have completed this. If you have any other questions, you are welcome to email any of us. We will get them to the correct person and then get those questions sent out to the entire group. We'll also be able to have the recording later on, so please pay attention to your email because that recording will be coming out so that you can receive further information.